Welcome to qnawire.
All right, we've got to propose a mechanism for the following transformation, as well as label any specific steps. This molecule is going to react with ethanol. All right, well, let's look at our substrate here. The first thing you may notice is that the bromine, our leaving group, is attached to a tertiary carbon. For this reason, we can almost totally rule out SN1, or SN2 rather. So it's not going to be an SN2 reaction. That can't happen at tertiary carbons. We can consider, is it going to possibly be E2, E1, or SN1? Well, E2 also seems unlikely because we do not have a strong base. This is a moderately strong base, but it's not a strong base. Essentially, if we had had maybe sodium ethoxide, a charged base, we could consider E2. But in this case, since we have a neutral base or nucleophile, E2 is out. Okay, so it's not SN2, it's not E2. Is it E1 or SN1? At this point, your usual hint is if there is heat or a delta, a triangle, then you can assume that it's going to be E1. If there's no heat, the typical assumption is that you're looking at SN1. In this case, though, there is one other hint that we may be looking at E1, and that's that if we do an elimination reaction, what we'll have created is a double bond here or here. And when we do so, that double bond will actually be in conjugation with this phenyl ring, which is very favorable. So if creating a double bond would lead to some sort of conjugation, either with another alkene or especially with a phenyl ring, then E1 or any elimination reaction becomes very favorable. So we're going to proceed as though this is an E1 reaction that will happen. So the first step in E1 is that bromine will leave. Giving us a carbocation here. Now our next step is that our base, in this case ethoxide, will come in and deprotonate this proton and create a double bond. Okay. There we are. That's our product. There's no specifically important steps in this particular reaction that would be named. There's no propagation or reduction or shifts. This next reaction we are asked to predict the product as well as show the mechanism. Okay, now in this case, we do have a charged nucleophile, which means that SN2 becomes likely. Is it possible to have SN2 at a secondary carbon? Yes. Okay, since we've got a charged nucleophile, we might also ask ourselves, do we have a charged base? Cl- is indeed a good nucleophile, but is it a good base? And the answer is no. The reason for that, or a way you can remember that, is that HCl is a very strong acid. That is, chlorine readily gives up hydrogen, which, if this is a strong acid, then this must be a weak base. The conjugate base of a strong acid is always a weak base. So chlorine is not a strong base, so we're unlikely to see E2 competing with SN2. So let's continue. We've determined that it's very likely to be SN2, in which case we'll see attack at the substrate at the same time that the bromine leaves. As follows.